The Influenza A Virus Seminar, aka Flu Virus Seminar, by me. Also, I'm still sick, so I'm gonna sound weird still. Anyway, is it enveloped or naked? The influenza A virus is enveloped. This means that the virus exits the host cell by budding from the cell's surface or other membranes. A naked virus does not bud from a host cell membrane, so they have no envelope. Hosts. Humans, mammals, birds are all hosts of the flu virus. Some mammal examples include pigs, horses, seals, and even whales. Some birds include ducks, geese, and swans. Genome type. Negative ssRNA, segmented and linear. And here's what all that means. SS stands for single-stranded DNA. Segmented means that it's made up of multiple independent nucleic acid segments. Linear means that it's a single continuous sequence without the ends joined together, so it's not a circle. And that little negative dash line means that it needs to be transcribed into a complementary positive, the little addition sign, RNA strand first. Transmission modes: human to human, animal to human, aka zoonotic. People with the flu can spread it to other people up to about 6 feet away. Doctors think that the flu virus is spread by droplets made when the infected people cough, sneeze, or talk, similar to COVID. The replication cycle. This little diagram shows how the flu virus makes copies of itself, but do you understand what's going on in there? No? Okay, I'll explain it to you. Glycoproteins on the surface of the flu virus bind to specific receptors on the host cell's surface, A. The A is not on there for some reason, and neither is the J. AJ is not on there, so just ignore that and pretend it's on there, right? Alrighty. This triggers a process called endocytosis, B, which brings the virus into the cell in a vesicle called an endosome. You see the endosome right there. Anyway, acidic substances build up inside the endosome, triggering the endosome's membrane to fuse with the virus's envelope. This releases the virus's negative RNA genome segments and viral polymerase into the cell's cytosol. That's shown in C. The viral genome enters the cell's nucleus, where the viral polymerase transcribes the virus's negative RNA genome segments into complementary positive RNA templates. That's shown in D. These templates are used to make copies of all the virus's negative RNA genome segments, which is shown in E. Replication. The virus's negative RNA segments are also transcribed into mRNAs, which is shown in F. And those are translated into proteins by ribosomes in the cytosol and on the ER, which is endoplasmic reticulum. That's shown in G. The flu virus glycoproteins go through protein processing in the ER Golgi network, which is shown in H, and are then transported to the cell membrane. Viral genomes and proteins get assembled into new viruses, that's shown in I, virus assembly, and leave the cell through a process called budding, which is shown in J. You can't see the J, but pretend it's there. This process surrounds the virus in a piece of the cell membrane containing viral proteins, which becomes the virus's envelope. And that's how it's replicated. Is there a vaccine? Yep. A vaccine is a substance that, when put into your body, it'll cause a protective immune response to the virus. When a person who has been vaccinated against a certain virus encounters said virus, like using this example, like the flu, the body should be prepared to fight the flu because of that vaccine. Important note: no, vaccines don't cause autism. That's the end. Bye-bye.